Let's talk about the checklist, all right? I've sat through a number of times at listening to people that go through a checklist for their tablets. Let's think of two things, good science and common sense. You have to rate each process step, okay? It's either going to be high, low, or no impact, so why validate it, okay? And again, this would be, if you use the SUPAC validation and use the SUPAC equipment terms, this makes it very clear. Okay, I've put together a very brief area checklist. Okay, and again, just to give you a sense of my thinking, for example, let's look at granulation. Obviously, this would be a high impact one, maybe. Okay, there is possibilities where it may not be. I can't think of too many, but granulation, it would be the speed, obviously, rate of addition, assuming you're going to granulate with something. Right, the time in which you do it. Drying, obviously, what your targets are and how long it takes you to be there. Compression, okay? But unless you pull these out and define why you're doing them or what the endpoints are or what the expected acceptance criteria is going to be, you've set yourself up. I've seen people try to validate everything, you know, dew point plus or minus 2 degrees and CFM plus or minus. I mean, these guys are working down in engineering limits. The equipment is capable, but the process in its dynamic state is not. Have somebody done the reality check with the guy who developed the technology, with the formulation guy, with the production guy? This gets back to our team point. All right? This scheme, and again, where does data review? What we found is with this data, once you've compiled, it allows you to do statistical process control, looks for atypical behavior. You look at where you expect the stuff to be within a range. And you can actually do continuous improvement on a process. Process comparability is another one. CPKs I've seen people use, especially in Six Sigma. Six Sigma, you see a lot of people, that's one of the buzzwords.